Young Eye or Eye project, and thank you also for the invitation. I am Clara Lim, and so today I have the honor to be the speaker for the Eye team. So first, what is the Eye project? It's a European project that aims to develop advanced therapeutic solutions for presbyopia. It includes 3 entities, the Universidad Complutense de Madrid and 2 companies, Makenovi and Alain Afflelou. Plus, we are 5 early-stage researchers working on a PhD thesis as part of the project. So all of our thesis will be on the presbyopia and contact lens innovations. So this project is based on 2 work packages. The first one is in coordination with Makenovi, and it deals with the better understanding of the advantages and drawbacks of the current solution for presbyopia compensation. So its aim is to develop a new contact lens prototype to meet the needs of the presbyopic population. So the PhD 1 and PhD 2 will work with Makenovi. Then you have the work package 2, which will be in coordination with Alain Afflelou, and it will deal with the technological tools that will be developed to collect and monitor the patient-reported outcome, clinical parameters, and environmental conditions in a continuous way while the patient is wearing the lens, so as to inform the clinician. So PhD 3, 4, and 5 will be working with Alain Afflelou. So as I told you before, we are 5 PhD students, and we come from various backgrounds, going from optometrist to engineer formations. I will now present you the PhD thesis of each one of us. So first, Alicia Lopez is the ESR1 working on a thesis named New Optical Designs. Her aim is to create a new multifocal contact lens design, and she will focus on the correction of astigmatism and presbyopia based on pupil independency, also on the extension of the depth of focus and on the evaluation of rotational stability during blinking. So after she creates her design, there will be a verification phase to prove and confirm that the lenses can be fabricated. Then she will proceed to clinical trials to validate her lenses. So up until now, her work has focused on the measurement of contact lenses commercialized using the NEMO device. So with this, she studied the contact lens designs and parameters, like the wavefront Wernicke coefficient, the asymmetries, and the pore profile. Also, she uses the CMAX Optics Studio software for the design part. She works also with a novel presbyopic eye model where she will add the contact lens data by transferring NEMO files to CMAX. With this, she will be able to run visual simulations, and she will also create her own designs. So I am the ESR2 working on the PhD 2 thesis, new materials for contact lens. So as you know, the cornea needs oxygen to have its normal metabolic activity. So that's why I would like to develop a new hydrogel with high oxygen permeability, but without using silicone, because some people do not tolerate silicone. I would like also to create a new contact lens with antimicrobial and anti-inflammatory properties. So for the moment, I am synthesizing materials to study the influence of diverse factors on the oxygen permeability, like the bulkiness, the chemical group, or the cross-linkers. To measure the oxygen permeability, I will use the polarographic method that is a method recognized by the ISO standards. In parallel, I am studying the different incorporation techniques to add the antimicrobial properties in my lenses. Now, Elsa Albero Ross is the ESR3 working on the development and validation of the presbyopic contact lens patient-reported outcomes instrument. Her aim is to develop a valid and reliable computer adaptive testing-based PRO instrument for measuring the patient's perspective of the multifocal contact lens performance. Specifically, the instrument will be a self-administered tool available through the internet. It will show high-quality measurement properties, provide a composite score and the proper subscale scores, and it will be initially available in Spanish and in English. So to achieve this, her work line has been divided into 4 phases: the content development, pilot testing and calibration, validity and reliability, and cross-cultural adaptation. So until now, she focused on the development of the item bank content. And for this, a review on literature, social media, existing PROs, and has been done, as well as 14 focus groups, including patients and clinical experts. After the analysis from the in vivo software of the most important themes and words surrounding the presbyopic condition, an initial set of 305 items across these 9 domains were identified. Currently, these items are under refinement and revision before being assessed by patients through cognitive interviews. After this, the pilot instrument will be ready for the phase of calibration and administration. Now, Darshan Ramasubramanian is the ESR4 working on the thesis named Computer Modeling of Eye Response and Adaptation to New Contact Lenses. His objective is to develop a computational eye model using a multiphysical approach capable of predicting the best contact lenses for each patient. So, after reading literature, he has suggested a first approximation of the mathematical model of the tear film thickness with evaporation, supposing that the eyelid were stationary. Then this model has been extended to experimental tests to compare the results based on the tear meniscus. So the tear meniscus height has been measured on 3 subjects using the optical coherence tomography. Then this height has been used in the model for the boundary conditions. And they were supposed to be equal size for both eyelids. So here you have the graph of the thickness of the tear film with evaporation over time. As you can see, near the boundaries, you have a sudden drop, and in the central region, you have sinusoidal oscillations called ripples. So these ripples are more visible for smaller tear meniscus. So we can conclude that the tear stability is related to the ocular meniscus, and where a larger meniscus gives greater stability. So, the next step of this model is to include the movement of the upper eyelid. Last but not least, Youssef Marashi is the ESR5 working on e-health and big data PhD thesis. His objective is to develop an application tool to monitor the quality, vision, and comfort of a patient wearing contact lenses. To do this, he will take into account clinical parameters, the patient-reported outcome developed by ESR3, and the environmental conditions. So indeed, temperature, pressure, contamination data will be taken from the weather station closest to the patient using his location. Also, the patient will be able to use the camera application program interface to take pictures and videos of his eyes. And these images will be processed by the server. So in particular, the blinking frequency can tell us at what time the patient is more comfortable with the contact lenses and in which conditions. And then we will be able to compare the result with the normal blinking dynamics where the patient doesn't wear contact lenses. So it is important to understand that this project, all these projects are interdependent. And for instance, the work on the contact lenses developed on work package 1 will be checked thanks to the tools developed by the work package 2. So now, if you want to know more about this project, we have a webpage, the ih2020.com, and you can also visit our pages on social media, on Twitter, in LinkedIn, or Instagram. So thank you very much for your attention. And so if you have any questions, please do not hesitate. Today we are all